Ahoy and welcome. They call me Clemenshelm and you're watching Codeship Testing Tuesday number 9. Last week we had a look at integration testing and unit testing. I showed you how to develop your code outside in with behavior-driven development, and we also had a short look at specifying examples for single components of your application. We'll go into more detail on this today. I'll show you how to get most out of RSpec with stubbing and mocking, and why RSpec examples are the perfect companions for your integration tests. When you work outside in with behavior-driven development, your scenarios take care of checking that your application works from a user's perspective. They don't care at all how you implement something. These scenarios are great for verifying that your application still works after you made a change, but they have two major disadvantages. The first one is debugging. When something breaks, it can be tricky to find out where the root of the problem is. Your failing scenario might show you an error message with a stack trace. But often the trouble is an entirely different part of your application. That's when you have to read through logs and start cumbersome debugging sessions. The second disadvantage is speed. Running your scenarios is slow. They test your whole application stack, and sometimes they even use a browser to check JavaScript functionality. If we run all scenarios of the Codeship web application, this will take more than half an hour. So integration tests are great for verifying that everything works as it should. But let's say we refactor a class of our application. Then we permanently want to make sure that we didn't break anything by moving things around. Unfortunately, this is impossible with integration tests because they are just too slow. This is why we write examples how our single components, like, for example, classes, should behave. These examples should be fast, so we can run them continuously while we make changes to a class. And they should only specify behavior of their own scope and ignore all behavior of other classes. Our scenarios are responsible for making sure that all our components work together, so we don't need to check that in our component examples. To write these examples, we use RSpec here. But there are spec frameworks for a lot of other languages that work similar. Check out the further info section below to find out more. Let's say we've got an application like the Codeship, where a user has many projects. A user also has a full name consisting of the first name and the last name. And we've got a project that belongs to a user. When the project name is not set, we'd like to have a placeholder containing the user's full name. So we write a scenario. In our Managing Projects feature, we add the scenario placeholder for projects without name. And the scenario is, given I'm signed up as Peter Parker, when I create a project without a name, then the project should be called Peter Parker's project. These are the step definitions for the scenario. So we split the username into first name and last name, go to the sign up path, fill in the first name and the last name, and click the sign up button. Afterwards, we go to the projects path, click the new project link, enter an empty project name, and click create project. And finally, we want to find the project with the given project name. When we run Cucumber now, it tells us that it expected to find the project's name Peter Parker's project, but it didn't find anything. Let's fix this by writing an example for the project. I'm just going to paste this in here. It should be named after the user if no name is set. So we make a new user with the first name Peter and last name Parker. We make a new project. We assign Peter Parker to the project, and afterwards the project name should be Peter Parker's project. So when we run RSpec now, it fails and tells us it expected Peter Parker's project, but it only got nil. But it's quite easy to fix it. In our project, we have to make a method name and say either read the attribute name and get its presence. This will return nil also if the name is blank, or return Peter Parker's project. And when we run the spec again now, it works. And running the scenario also works. Great. But wait a minute. We filled in Peter Parker. So now the project is called Peter Parker's project, no matter what user it belongs to. We strictly followed the guidelines of behavior-driven development. Make the example pass with the least effort. So the next step would be to write the same scenario and the same example with a different username. In simple cases like this, I usually follow a different approach though. I use a helper method called randomName to make this work. So what it does is it takes the letters A to C, converts them to an array, picks 5 of them and joins them together. I can quickly demonstrate it on the IRB shell. So we get 5 random letters every time. So let's generate the first name and the last name here. So 2 times we need a random name. And we assign the first name and also the last name to the user. And we also fill them in down here. Just one final thing, let's put this helper method into the spec helper so we can also use it in other examples. Okay, right at the bottom. So when we run RSpec again now, RSpec fails again because here's our random name and it still returns Peter Parker. So to make it work, we need to fill in the user's full name. Instead of Peter Parker, we write user full name and run RSpec again. And now it worked. And also if we run Cucumber now, it still works. But what's the problem with this example? We're not only testing the project's behavior, but also the user's. When we change the implementation of the user's full name, like the last name first, and then the first name, our example will fail. This is unexpected because the project is still named after the user. So actually the example should still work. When we have a large example suite, these dependencies can cause a lot of work. One little change could lead to dozens of failing examples throughout our whole application. This also means that we would have to run all our examples after every change to make sure we didn't break anything. But wasn't this our problem with integration tests that we wanted to solve by specifying little examples? As long as there are dependencies on other components in our examples, we will always run into this kind of problems. So how can we solve them? By stubbing all behavior of other classes the way we expect it to work. Let's change our example to use stubbing. Instead of the first name and the last name, we just need a full name, which would be a random name. And instead of assigning the first name and the last name to the user, we just stub its full name method. So the full name should be our generated full name. And also down here in the expectation, we want to fill in the full name. Stubbing simulates a method by simply returning the value we've specified. So our user's full name method is never called. And this way we're independent of its implementation in this example. But there is one more dependency on the user. If we call userNew, this will invoke the constructor method of the user, which could also make our example fail. In fact, we don't actually need anything from our user, but its full name. So we can just mock our user model instead. A mock is an object that we can use in behalf of another object. It has got only the functionality we assign it. So we could just say mock model user and assign it the full name. Mock model is RSpec's way of simulating a model. The advantage is that we can use it also as an association, like here in the project. If we run RSpec now, our examples work again. There is also a more generic way of mocking an object, a double. So we can just replace mock model user by double here, but the example fails now because we can't use a generic double as an active record association. However, we can just stop the association as well to make it work. So we stop the user and assign it the double here. Running RSpec again, it works now. This is the version of the example that I would prefer, because it is concise and has no dependencies on other components. But isn't it dangerous to work with mocks? In the end, we never know in our examples if the class we're mocking will behave the same way as the mock. What if we assume something that doesn't work the way we mock it? Well, that's what our integration tests are made for. Running our integration tests makes sure that everything we assumed in our component examples holds true in the real world. This is especially great for stubbing behavior that doesn't even exist yet. Your integration tests will always remind you to implement this missing behavior. But we'll look into this in more detail next week. Then I will show you how to design your application properly using behavior-driven development with RSpec. I hope you liked this episode, and as usual, I'm looking forward to your comments. Special thanks to Amrit, who suggested the topic for this week's episode. So have a beautiful week and see you next Testing Tuesday. Oh, there's one more thing. Always stay shipping.